this lesson, we are going to learn about confidence intervals. We'll get an overview of what they are and how they're constructed in general. Then we'll use them to estimate a population mean. And in another lesson, we will learn how to do this with proportions. So far in this course, we've estimated population parameters, such as the population mean mu, by calculating a single point estimate, such as the sample mean x bar. Have you seen this movie Karate Kid, the original? It's awesome. And in this movie, there's a scene where Mr. Miyagi, the teacher, is trying to catch a fly with chopsticks. His student Danielson says, "Wouldn't it be easier to use a fly swatter?" Miyagi says, "A man who can catch a fly with chopsticks can accomplish anything." So of course Daniel wants to try, and Miyagi is kind of laughing. He's probably thinking, I have zero confidence that he's going to be able to catch this fly with chopsticks. I've been trying my whole life and haven't been able to do it. So this is relevant to confidence intervals, you may have guessed, as I'm focusing on the word confidence, because using an interval to estimate a population parameter, rather than just a single point estimate, such as a sample mean, using an interval will increase our confidence that we have caught or will be able to catch the true value of the population. So, a sample statistic is the best point estimate of a population parameter. For example, the sample mean is the best point we can use to estimate the mean of a population. Now we'll be able to learn how to estimate population parameters using a range of possible values called an interval estimate, and we call it a confidence interval because we can change the size of the interval estimate based on how confident we decide we need to be. Now, here's an example of constructing an interval to estimate a population mean. The confidence interval will have boundaries that are calculated starting with the best point estimate and expanding the net from there by adding and subtracting a margin of error. For example, suppose we want to estimate the mean of a population within 3% margin of error, and we have a known sample mean of 24.02. We could state the interval estimate in the following ways. We could say the sample statistic plus or minus the margin of error, or we could actually calculate a lower boundary and an upper boundary and write it in this interval notation with the symbol for what we're estimating in between. Notice that's the population mean symbol because that is what we're trying to estimate. And if we calculate the lower boundary, we have 23.99, and calculating the upper boundary, we get 24.05. We could also state it this way in interval notation. Suppose we report these results in an article and later a reader wants to figure out what the sample mean was and what the margin of error was. In other words, we only gave the actual interval, not the original sample mean and margin of error. So we can work backwards from the boundaries. In general, the point estimate is the midpoint or average of the interval boundaries, which makes sense because we started there. We started at the center, then we added a margin of error and went down a margin of error. So we traveled 2 margins of error to get to those boundaries. So it makes sense that if we just take the average of those 2 boundaries, we will arrive back at the center. And likewise, the margin of error is half the distance between the interval boundaries. So when we moved those 2 margins of error, we have a distance between them of 2e, and we divide that in half to get back to e. So perfect sense, right? Subtract the boundaries and divide by 2 to get back to the margin of error. So using our example here, we have our 2 boundaries averaged to a midpoint of 24.02, which was our sample mean given. And the margin of error, subtracting them and dividing by 2, we do arrive back at the margin of error. We control the size of the margin. Now in this example, the margin of error was given to us, but that's not typically how these questions go. Normally we have to calculate the margin of error, and different factors can affect the margin of error, including the confidence level and the sample size. So in the next video, we'll start to talk about how those things can affect the margin of error and how we balance them out when deciding how confident we're going to be and how much sample data to collect.